Okay, we are going to start corrosion. It's degradation of materials. So corrosion, um, it's a chemical reaction. So we are going to discuss some questions, few questions on that corrosion reactions. So if you look at this electrochemical cell here, we have zinc and copper. So when we have zinc and copper with an electrolyte and connected, when the electrons can flow from one metal to another metal, this reactions will happen. So one metal will act as an anode and one metal will act as the cathode. So to identify which metal is what, we look at this EMF series. So when you look at the EMF series, the top, when you compare the two metals, the one at the top will act as the cathode and one at the bottom will act as the anode. So you need to remember this. So without knowing which one is the cathode or which one is the anode, we won't be able to write the reactions. So we can't say a metal is always at one metal. For example, if you consider copper, you can't say copper is always acting as a cathode or always acting as an anode. Depending on the other metal which we have, sometimes the copper will become the anode, sometimes the copper will become the cathode. For example, if you consider copper with maybe this silver. Silver is at the top, so silver will be like acting as the cathode and copper will act as the anode. But if you consider copper with maybe chromium, copper will act as the cathode and chromium will act as the anode. Do you understand what I mean? So always when you compare the two metals, which is at the top will be your cathode and which is at the bottom will be your anode. Does that make sense? So when after identifying which metal is becoming cathode and anode, we will be able to write the reaction. So, and in the anode, what is happening is anode is losing electrons. So we call this oxidation reaction. And if I write here, if you look at zinc and copper, which one is the anode and which one is the cathode? Can you tell me first? Looking at where they are in the EMF series. So we have zinc here and we have copper here. Which one is the anode and which one is the cathode? That's right. So zinc is the anode. So what is happening in the anode? In the anode is losing electrons. So zinc is losing 2 electrons and zinc is becoming zinc ion, zinc 2+ ion. So that we call the oxidation reaction. Are we all good? So what do we have as in the cathode? Cathode is gaining electrons. So that means, so these two metals are in solutions, their own solutions. So zinc is in zinc solution, zinc sulfate, and copper is in copper sulfate. So in this one, you have copper plus and also SO4 negative. So these ions are in the solution. In this side, if you consider this side, zinc ions and also sulfate ions are there. So what is happening is it's gaining electrons. That means these copper ions are gaining electrons. So copper ions in the solution is gaining the 2 electrons, which is removed from the zinc, and it will becoming copper solid. Do you understand what I mean? So you can see in the anode, zinc solid is becoming a solution. Do you see that? This is a solid. Zinc is a solid. Zinc is a solid now because it is losing electrons. This is becoming an aqueous media because ions are in the solution, isn't it? So what's happening to that metal? Is it gaining more metal or is it losing the weight? What is happening? It's losing because it is becoming an ion. So it is adding zinc to the solution from the metal. So corrosion is that. So we are losing that metal. In the anode, what is happening? Copper solution, copper ions in the solution is gaining electrons and building up on the cathode. So that is getting bigger. So copper plate is becoming bigger and the zinc plate is becoming smaller. Do you understand what I mean? So cathode is protecting, cathode is building up, anode is losing, anode is corroding. So that's what happening in corrosion. Are we good? Any question? No questions? Okay, first thing is you should be able to identify the anode and the cathode. So by looking at the EMF series, you can identify which one is what. Then after identifying that, you should be able to write the two equations. And when you write the two half cell equations, we can write the overall equation just by adding these two together. So when you add these two together, you add the left-hand sides together. So left-hand side, you have zinc, copper, ions, and electrons. So that will be the left-hand side of your overall reaction. And in the right-hand side of your overall reaction, you have zinc, ions, and copper solid. So can you please write me the overall solution? Can you please tell me what you have in the overall reaction? So this is what in the left-hand side, and in the right-hand side, we have zinc ions plus 2 electrons plus copper. Am I right? Is that right? So this equation we call the overall reaction, overall equation. But here in both the sides, you have electrons. So you have ignore this one because it's cancelled out because it is in both the sides. Am I right? So you can write the equation now. Zinc plus copper ions, and here you have zinc ions or copper. So this we call the overall reaction. Any questions so far? No questions? Now, after writing these reactions, we will be able to find out the potential difference. So potential difference is always cathode voltage minus the anode voltage. So cathode is at the top, am I right? And anode is at the bottom. So this number minus this number will give you the delta V naught. I will tell you why we call it V naught, but will you be able to find me the potential difference? Cathode voltage minus the anode voltage, what do we get? What do you get? It is plus 0.34 minus 0.76 something. Yes, 763. What do we get? Do we all get this? So this is a positive value. That's why it is possible to have a current in that direction. So always, if it is in the right direction, then we have a positive number there. So delta V naught is 1.1033. Do we all get that? Anyone got anything else? No? All good? So these voltages here, if you look at this one here, these are standard electron potentials. Standard electrode potential means it is at, the solutions are 1 m, 1 moles per liter, and it should be at 1 atm pressure and 25 degrees Celsius. If this solution concentration is different, or else if the temperature is different, this value need to be adjusted. So we have a different equation to find the delta V. We don't call it delta V naught. We call delta V naught only when we have standard conditions. So what are the standard conditions? 1 m solutions in both the electrodes and 1 atm and 25 degrees Celsius. Are we good? Now it covers all the theory that you need. One more equation to go, then that's all you have as the theory for the corrosion. If you don't understand, if you need me to go through again, tell me. Otherwise, we'll move to the next equation. Are we all good? Do you need time to write down anything? All good? Okay. Now, this is for standard electrodes, but if you consider non-standard conditions, so what can be the non-standard condition? Your temperature will be different. Your solution can be different concentration. If your temperature is different or solution is in different concentrations, we can find the delta V using this equation. Here in this equation, we have this one. We already know how to find it because that is under the standard conditions. So how do we find it? We just look at the EMF series and we find the delta V naught. We already did it. And here we have minus R means the gas constant, T means the temperature in Kelvin, N is the number of electrons contributed to the reaction. In the previous one, we had 2 electrons. Am I right? And F is the Faraday's constant. So they are known values. And here Ln, we have Ln here. And these are the concentrations of the solutions in the output side. So in the output side, if you have concentration, maybe a different value, maybe 0.1 moles per liter. So then this capital X will be 0.1, and whatever the number, when we balance the equation, we get a number here. So that number will be this one, this small x. So we do a question, so you will be fine with this one, okay? So that the numerator is relevant to the outputs in the right-hand side of the equation, and the denominator is relevant to the input side, left-hand side of the equation. So we are going to do a question, so you will be fine when we do a numerical question. So do you understand the difference between standard and non-standard conditions? And in the non-standard conditions, we are going to use this particular equation. However, we can simplify this equation. If the temperature is 25 degrees Celsius, we can simplify this equation to one of these. So the difference between these two is here you have ln, here you have log. Both are true depending on whether you like to use ln in your calculator or log in your calculator. Are we good? Any question? No?
RT divided by NF times LN times X, Y.
Yes. So these X are molar concentrations. Capital X, capital Y, capital A, capital B are molar concentrations of the solution for different elements. And simple A, B, X, Y are when you're balancing an equation, if you have something in front of that particular element, that will be your simple X, Y, A, B. We'll do a question, so you will be fine after. Are we good? Any question? Can I move on? Do you need time? I will do one example, then you can do all the questions in the tutorial, okay? Again, reminding you guys have your second quiz in week 13, not in week 14. So this is week 11, not next week, the week after.
We have final exams.
I didn't go through that.
The speaker's guide says this presentation, but message the coordinator that he has want to exchange back to final exam. So we have it in the final exam.
Oh, that's good, I think. Having a final exam is a good thing. You will learn only, like you study only if there is an exam. Am I right?
Yes.
So, okay, so can I move to an example? So let's do an example. Okay, so in this example, they are saying, predict whether the following reaction is feasible or not. Feasible, if it is feasible, your delta V should be always a positive value. So you can find the delta V, and if the delta V is a positive value, then we can say the reaction is feasible. Okay, so that's how we say check whether the reaction is feasible or not. So they have given us the overall reaction. So now, can you tell me which one is the anode and which one is the cathode? Is the nickel or Ag? How do we find it? In the anode, what is happening? Oxidation is happening. Anode is losing electrons. Which metal is losing electrons? Nickel is losing electrons. So this will be your anode. And which one is gaining electrons? Silver is gaining electrons, so that will be your cathode. Okay, that's good that you identified it. So you can see the concentrations in the solutions are not 1 m. So we can't use that delta V thing to do it. So here they have given you the standard voltages. So we can find delta V naught in the standard conditions. That means 1 m solution and 25 degrees Celsius. So this is always cathode minus the anode, top minus the bottom. So this one is the higher number, am I right? The cathode is Ag, which is the higher number. So 0.8 minus 0.25. So when you add these two, we get 1.05 volts delta V naught. So just by looking at this, can we say that this reaction is feasible? Can we, just looking at the delta V naught, can we say it is feasible? So I told you, I'm asking this because I told you when the delta V is more than one, is a positive, we can say the reaction is feasible. So we found delta V naught just by looking at this number. Can we find out whether it is feasible or not, or do we have more steps to do? What's that? Feasible? Above 1, but that is the under the standard conditions. Do we have the standard conditions? No, we don't have standard conditions. Our conditions are not 1 m. The concentrations are different. So what we need to do? We need to find the delta V using this equation. You can either use the log equation or ln equation. It doesn't matter. We took the log here, and for the next question, we'll use ln. Okay. So here, yes. Any question? Okay, so you can see this one we already found, which is 1.05. And this number it's given. And how many number of electrons are contributing to this reaction? How do we know how many electrons are contributing to this one? 2 electrons. How do we know that? Yes, so 2 plus, this means this also 2 times ions, isn't it? So there are 2 electrons contributing in this reaction. So this is 2. Am I right? And here X's and Y's are your outputs. So if you look at your reaction here, that we are talking about these ones. When you look at the concentration, we don't talk about we talk about the concentration for the aqueous media. So there is only one ion. Am I right? So what is the ion we have? We have the nickel, isn't it? So if you look at the nickel concentration is given to us 0.001 moles. Am I right? And when we are balancing equation, so when we balance the equation, do we have how they have balanced the equation? Do we have anything in front of this Ni? Just 1, isn't it? So this number will be 1. Am I right? And at the bottom, we are looking at the input side, left-hand side of the reaction. That means we are looking at this side. Again, aqueous media, we have silver. So silver concentration is 0.1. And we have to have 2 as this number here. Am I right? Because there are 2 silver ions are there. Am I right? Any question? No questions? So when you put these numbers in your calculator, when you put all these numbers in the calculator, you can have a look. Just put the numbers in the calculator. We should get 1.0795. Now we can say this is more than 0, so it is feasible. Does that make sense? So how to balance the equation will, after you finish this part, I will explain you how this balancing part need to be done, okay? So can you check whether you get the same number? Are you okay up to here? Anyone have any question? All good?
No.
Because now I'm not going to explain the rest of the questions. If you understood this, I think you are fine to do all the questions by yourself. You guys okay? Any question? Do we get this number 1.0795 volts? We get it or not? Ah, that's fine. That's fine. It's maybe a small. That's okay. Yes. Okay. Now, can you tell me, are we able to tell now whether the reaction is feasible or not? Can we say it now? Boys, you said your this table. You said that it is feasible before. Now, can you tell me whether this is feasible or not? What's that?
No.
Why? Is this negative?
This is positive.
This is positive now,
Yes.
isn't it? So if it is positive, if this is positive, this is feasible. When the delta V is positive, it is feasible. Any questions? No questions? Okay, now well, let's see how this balancing part need to be done. For example, boys, if you want to talk, you can go out and talk and come back.
Out.
Okay, so in case if they haven't given you this equation, let's see how to write the equation by ourselves. So we look at here, we write the equation just by looking at this one. So can you tell me, we are looking at zinc and, nickel and, what did we have? Nickel and silver, isn't it? Yes, nickel and silver. So you are looking at nickel and silver. I want you to write the equation. So in the previous question, they have given you the equation. Now, can you please write the equation, AG? Can you write the half cell equations? I already told you how to write it. So first tell me which one is what? Cathode and anode. Identify the cathode and anode. By looking at the EMF series, how do we identify which one is what? The one at the top is cathode. So this is the cathode, am I right? And this is the anode. Am I right? So how do we write the anode equation? Anode means your nickel is losing electrons. So nickel will become this, isn't it? So you just write this equation. In the cathode, what is happening? Opposite is happening, gaining electrons. So you write this one in the opposite direction. So you start with Ag and going to this side. Am I right? Opposite direction. So that will be Ag is, sorry. I told the other way around. So in the anode, you are writing the opposite reaction, and in the cathode, you are writing the right reaction here, given reaction towards the left. So this one, you are writing Ag is gaining electrons. So Ag plus is gaining an electron, and it is making Ag. Now, if you look at these two, before you add, you have one electron in the uh, reduction reaction and two electrons in the oxidation reaction. So what we do is, so when one nickel atom is becoming an ion, it is releasing two electrons. Those two electrons will be gained by two silver ions. Am I right? So this should need to be times by 2 all the way, like from start to the end. Why we times by 2? Because nickel is releasing two electrons. To gain the two electrons, we need to have two silver ions. Am I right? Now you add them. When you add them now, nickel plus 2Ag plus 2 electrons is equals to nickel 2 plus 2 electrons plus 2 Ag. So that's how your 2 electrons will cancel out from both the sides. So that's how we got nickel plus 2 Ag plus is equals to, that's how we got this balancing this two in front of some elements. Does that make sense? Are we good? Any question? Okay, if you don't have any questions, you are ready to go and do the tutorial question by yourself. Can I move on? Okay, so I'll give you time for doing this. Read the question, understand it, identify which one is what, and do it by yourself. I'll help if you need help. Pure lead electrode, copper and lead immersed in solutions of their respective divalent ions. So divalent is two plus, so 2 plus ions. So for concentration of copper, so copper concentration is given to you. Copper concentration is given to you. Lead electrode oxidize. So oxidation is happening with the lead. So oxidation is happening in the anode, isn't it? So lead will be your anode. This is your anode. And yielding a cell potential of. So this is your delta V. Calculate the concentration. So they're asking you to find the concentration of lead ions if the temperature is 25 degrees Celsius. So first we need to write the equation. So what is happening? Oxidation is happening with lead. Lead is Pb. So Pb is losing electrons. Am I right? This is the reaction at the anode. Do you agree? Because it's losing electrons. Oxidation, losing electrons, anode are same thing. So like same. Anode is losing electrons and we call it oxidation reaction. Cathode gaining electrons, we call it reduction reaction. So copper, what is happening? Copper is gaining electrons and copper will become a copper solid. Now when you add these two together, this will be Pb plus copper 2 plus 2 electrons, Pb 2 plus 2 electrons plus copper. So electrons will cancel out and you have Pb plus copper ions equals to Pb. So this is what we have. You can use either the log or ln. Let's use the log and in the next question, let's use the ln. So here, this is given to you. Am I right? 0.507 is given to you. Find out which one we know, which one we don't know, and we figure it out. So where is the attendance sheet? I have to collect your bonus question. Who has the bonus question? No, it doesn't say standard. If it is standard, they have to raise it. I'll come and collect the bonus question. Okay? So what is the N in this case? What is N, guys? How many electrons are contributing? 2. Okay, now output side, do we know the concentration in the aqueous media? So we only have 1, we don't have 2. So you don't need to consider, like, you know, the other one is a solid. So it doesn't, we don't talk about the concentration there. It's pure one. So in the aqueous media, do we know this concentration? Do we know the concentration of lead ions in the solution? That's what they're asking us to find, isn't it? So this is what we need to find. This is what we are going to find. But simple X is 1, isn't it? Simple X is 1 because you have just 1 in front of this. And how about the A? This number is given to us, which is 0.6. And again, we don't have any, we have just 1 here. Am I right? So these are the things we know. So we can write 0.507 is equals to delta V naught minus 0.0592 divided by 2 log. We don't know. I just put this one as x. X we need to find, okay? And this is 0.6. So this is what we have. Am I right? And this one is not given to us. Can't we find this by looking at the EMF series? We can find it, right? So let's find it for copper and lead. So if you go here, tell me for nickel and lead, nickel is this. Copper is this. So what is the delta V naught now? Top minus the bottom. So what do we get as this one? Yes. My mistake. Nickel and lead, am I right? Lead. Sorry. Lead and copper. Okay, now we are right. Copper and lead, sorry. So that will be delta V naught will be 0.340 minus 0.126. So what do we get? 466. Do we all get this? 0.466 volts. Okay, now let's go and put that in our equation. So let's move to our equation here. So this one we found 0.466. Now you know everything. You need to make the X the subject. So you guys should be okay with maths part. Can I give you a few minutes for you to solve this? So we can take this log part. You do your calculations, okay? I'm just doing it here, but you don't have to look at my calculations. You can work by yourself. Is this right? So can write like this. Can I know what you get here? I don't have my calculator. This part, what do you get? So if you have any question regarding the calculations, let me know. Are you sure that we get this big number? 0.466 minus 567. So it is negative. So this part is negative 0.041. And we times that by 2 divided by 0.0592. So that will be negative 1.385. How do we take the log inverse now? So how we can, so x over 0.6 will be equals to 10 to the power. Log means base 10, isn't it? If you use ln, that will be e to the power. So you have this now. So you can make the x the subject. So if you make the x subject, x is equals to 0.6 times 10 to the power 1.385. So you can find the x. So what do we get as the x? Yes, that's right. So this is the concentration of the lead. Is there anyone who didn't understand this part? It's the same thing. It's not hard. Okay, so can you do this one? Use the ln this time, okay? So we'll familiar with the other equation. We should get the same answer regardless of which one we use. Again, it is 25 degrees Celsius, so we can use these numbers. In case if it is not 25 degrees Celsius, what we need to do? We need to go with the basic equation here. You need to put the value here. So you have to use this one if it is not 25 degrees Celsius. Okay, these two are only true when the temperature is 25 degrees Celsius, because we just put these numbers in the calculator, then we get this number here. Okay, so all right, so I'll give you time. I want you to find the right answer. You need to write the equations you have to decide which one is what, whether which one is anode, which one is cathode, and yeah. So I'll give you time. If you need my help, you can tell me. So who has the bonus question?
The other surgery, so fix it. Yeah, and so and always remember, really big things, but this one was so bad that we were like, so we went to get this really, thought that that pain, but when I was doing it, but now,
Okay, here. How you're going with this one? An electrochemical cell is composed of pure nickel and pure iron electrodes immersed in a solution of their divalent ions. If the concentration of nickel and iron like this, respectively, what voltage is generated at 25 degrees Celsius, the respective standard, this one is standard reduction potentials. You see that? Standard, oh yeah. So nickel and, so this is for nickel and this is for iron. So now by looking at these numbers, which one is at the top? So when you consider in the series voltage is decreasing, which voltage is higher here? Which number is higher, negative 0.25 or negative 0.44? This one is higher, isn't it? So this will be your cathode and this will be your, am I right? So your delta V naught will be negative 0.25 minus negative 0.44. Am I right? Is that right? So what do we get here? So if you write the equation, what should be your equation? So in the anode, it is losing electrons. In the cathode, it is gaining electrons. So when you add these together, you have so this is your overall equation. Am I right? So this is 0.19 volts. Is that right? Okay, now you should be able to proceed. We are going to use the Ln equation this time. So delta V is equals to delta V naught minus 0.02568 divided by N Ln. We only have two. So I'm going to write Fe concentration divided by Ni concentration. Am I right? For both, we have one. Is this right? N is 2, that's right. So this is two electrons. This we found 0.19. This one is given to us, which is 0.002. This is given to us 0.4. So we know everything. You put these values in the calculator and find me the delta V and find me the right answer among the A, B, C, D. They're both the same. They're both the same. Okay, so here the iron is in the aqueous media. Only the iron is in the aqueous media. The one which is Fe or the nickel, that is the pure solid. So it's a solid. So concentration, we talk about the solution. So solution is this one. Ions are in the solution. Does that make sense? So this is 100% solid. This one is the solid. But this, the iron is in the solution. So we are talking about the concentration of the solution. So you only consider this ions, not the metal, not the solid. What do we get? That's the answer for delta V. (0.12). So answer is C. Is that right? So this will be our answer. Do you all get the answer as C? So those are the two numerical questions we have. Are you guys okay with doing this? It's not that hard. If you do a few questions, the procedure will be the same. Are we good? Okay, now we have the third question. Can I move to the third question? Anyone need more time? No? Okay, third question. Briefly describe the two techniques that are used for galvanic protection. So corrosion can be prevented, like, we can have some coatings to prevent corrosion. But if you consider this reaction in the reaction side, how we can protect a metal? Which metal is corroding, anode or the cathode? Corroding the anode. Cathode is protected, isn't it? So by purposely selecting an anode, which is like, purposely making the structure that we need to protect it as the cathode, we can protect it, isn't it? For example, you have here, I'll show you. So we have a steel pipe. If we want to protect it, we can select a material which is an anode. So how do we select a metal which can be act as anode? You look at the EMF series and you find something which is below iron, isn't it? So the one at the top is the cathode. So we select one which is below the iron. So magnesium is below the iron if you look at the EMF series. And we can connect this one to the steel pipe. So steel pipe will be protected. Magnesium will be decaying with time. So we can replace the magnesium plate. So we are protecting the steel. And also sometimes we have metal parts connected with a nut and bolts. So we select the metal sheets or the big structure as the cathode, and we select a material for the nut and bolt which can act as an anode. So nut and bolt will corrode, but we can replace it easily. But if the structure is corroding, then it is hard for us to replace. So we select the nut and the bolt in a way that it will act as an anode. Does that make sense? So we only have to replace the nut and the bolt, and we are protecting the rest of the things. Are we good? Okay. So that we call the cathodic protection. So we are using a sacrificial anode. So anode is sacrificing, but we are protecting the cathode. So that we call the cathodic protection. Are we all good? Any question? The other part is, this is happening because the electrons are flowing, isn't it? Because electrons are flowing, the solid is becoming an ion and is combining with the solution. But if we can provide some electrons in the opposite direction, then it doesn't happen, isn't it? So we can supply an electric current to prevent the electrons are moving. So here we call that the impressed current protection. So what we are doing is we provide a stream of electrons to the metal so that metal won't lose the solid. Are we good? Any question? So these are the two methods. Okay, now we have multiple choice questions. I'm not going to give these ones as the bonus question. I'll give you a separate one. Can you tell me the answer for this? Corrosion that occurs as a result of concentration cell is known as crevice corrosion, galvanic corrosion, pitting corrosion, erosion corrosion. So what do we mean by erosion corrosion, for example? It's with the force. For example, you have metal pipes. So fluids or the water or any other fluid is flowing here. So these points, the forces are applied on these points and the corrosion is happening much faster because of that force. So you can see these parts are elbows, any weak points like, elbows, any junctions, they will corrode because of they will corrode faster because of the force. It is force and the chemical reaction both happening together. And what do we mean by pitting corrosion? Pitting corrosion is happening when you have some defects on the surface and the corrosion is initiated at these defects and it is happening like, going like this in the vertical direction. So that we call the pitting corrosion. Galvanic corrosion, that's what we discussed now. And previous corrosion is like when you have a confined area and when there is a difference in the oxygen levels, it will happen. And you have more information in your lecture notes, okay? So what should be the answer for this particular question? That is galvanic, am I right? Next question. So next question, which of the following factors can influence the corrosion behavior of metals in an environment? So temperature. Do you think the temperature is affecting? If the temperature is high, reactions are happening faster. Even when you can imagine, even to dissolve some sugar in water, if you have hot water, it will dissolve it. So any reaction will get faster because of the temperature. So humidity. Again, humidity. Water is a favorable environment for corrosion. So it is again affecting corrosion. How about the presence of impurities? Again, presence of impurities, the reaction part and also the environment that will change because of the impurity. So the answer should be 1. D. Next one. Corrosion prevention techniques include coating the metal surface, cathodic protection, using sacrificial anode. What is the answer? Oh, there. So they are easy questions. Okay, now this is my bonus question. It's not in your tutorial, so you need to take a photo. I want you to find which one is what. What do we mean by uniform attack, galvanic corrosion, pitting, intergranular corrosion, selective leaching, erosion corrosion, stress corrosion? What's that? Yes. So you have definition. So you need to figure out which one is what. So you have this in your lecture notes, okay, theory. You need to read the theory and do it. Okay, that's all from me.